Okay, so let's talk about something we all think we understand, school grades. We see the report cards, we see the test scores, but what if those numbers are actually telling us the wrong story? Today, we're going to dive into a pretty radical new way of thinking about how students learn, and it's all about moving past simple grades to understand the actual architecture of their knowledge.
You know this puzzle, right? Every teacher, every parent has seen it. You've got two students, they're in the same class, they get the exact same grade. On paper, they look like twins. But in reality, they are just worlds apart in how they think, how they struggle, and how they succeed. So, what is really going on there?
So let's get really concrete with an example from the source material. Imagine student A. We'll call this student the algorithm runner. This kid is a master of mechanics. You give them a formula, they will solve it perfectly, every single time. But throw them a curveball, a totally new problem they haven't seen before, they just freeze up. Then you've got student B, the creative connector. This student sees the big picture, they make these incredible intuitive leaps. But their weakness? They might just rush through the basics and make silly mistakes. And the punchline? They both end up with the exact same grade, a 7.
And that right there is the fundamental problem. A grade of 7 tells us they're kind of average, but it gives us absolutely zero insight into how they're learning. Student A, the algorithm runner, needs help with flexibility, learning to think outside the box. Student B, the creative connector, needs help with structure, with nailing down their knowledge. They need totally opposite kinds of help, but our current system is completely blind to this.
So how do we fix this? Well, the idea is to stop looking at learning as just some flat score and to start seeing it as a structure, like an actual architecture of experience that's being built inside each student's mind.
And this brings us to this really cool concept called geometric pedagogy. It's a total paradigm shift. Instead of asking, how much does the student know? The question becomes, what is the shape of their knowledge, right? Is it like a narrow, rigid tower, or is it more like a sprawling, interconnected city? This model suggests we can actually map a student's mind using 3 key geometric properties. First up is dimension. Just think of this as the richness of their knowledge. Does a student know one fact all by itself, like a little island? Or is that fact connected to dozens of other ideas, forming this dense, rich network? Then there's curvature. This is really all about cognitive flexibility. A mind with low curvature is pretty rigid. It thinks in straight lines. But a mind with high curvature is flexible. It can bend and adapt to new or unexpected problems. And finally, there's continuity. Is their understanding a solid, connected landscape? Or is it kind of Swiss cheese, full of holes and missing pieces?
And this is where it all kind of clicks into place visually. If you look at this model, you can see student A's mind. It follows that super narrow, efficient path. It's great for problems they've seen before, but it's very rigid. Now, look at that complex, tangled web of connections. That's student B's mind. It's incredibly high-dimensional, it's creative, but boy, it can be messy and hard to navigate. For the first time, we have a way to actually see the massive difference that a simple grade of 7 just completely hides.
Now, this isn't just some cool metaphor. The real goal here is to build a practical, usable bridge from what we know about the brain all the way to what teachers are actually doing in the classroom every day.
Now let's be real for a second. The whole field of neuroeducation has been just full of myths for years. Stuff like left brain/right brain personalities, or the idea that we only use 10% of our brains. They're just wild oversimplifications. This geometric model is all about replacing those myths with a real, structured connection.
Okay, so here's the secret sauce, the key innovation. For decades, we've been trying to make this huge leap, directly from the brain, the physical hardware in step 1, all the way to classroom performance in step 3. But that leap is just too big, and that's where all the myths come from. This model introduces a critical middle layer, the geometry. It argues that the brain's physical activity creates the shape of our experience, and it's this invisible architecture that really drives learning. It's the missing link we've been looking for.
And this is where things get really, really powerful. This model has massive implications for how we think about learning difficulties.
The traditional view looks at things like ADHD or dyslexia as a deficit, right? Something is missing or broken in the brain. But what if that's just the wrong way to see it? What if these aren't deficits at all, but they're just students trying to navigate the world with a differently shaped mental map?
Let's take ADHD. The old view calls it an attention deficit. Something's missing. So the intervention is to try and compensate for that missing piece. But the geometric view reframes it completely. It's not a deficit. It's an instability of the mental pathways. Thoughts jump all over the place because the map itself isn't stable. This totally changes the intervention. Instead of trying to fix a missing skill, the goal becomes providing external structure like clear routines to help that student stabilize their own unique mental map.
And this new perspective works for dyslexia too. Instead of seeing it as just a deficit in processing sounds, it's seen as an atypically organized mental map that connects sounds and symbols. So the goal isn't just to drill some supposed missing skill over and over again, it's to help the student actually remap the connections inside their own unique mental space, to work with its shape, not against it.
So at the end of the day, this changes everything for the teacher at the front of the classroom. It completely reframes the most fundamental question they have to ask themselves.
This quote from the source material just nails it. The job isn't just about delivering content anymore, it's about being a kind of mental architect. Does this student's really rigid mind need an intervention that's going to increase its curvature, its flexibility? Or does this other student's really chaotic mind need help increasing its continuity and its structure?
And that leaves us with this huge kind of visionary question. For centuries, we've had this one-size-fits-all model for school, where we ask kids to conform to the system. But what if we could really start to understand and map the unique geometry of each child's mind? Could we finally build an education system that is flexible enough to actually fit them? That is the incredible promise of this new blueprint for learning.